Hello and welcome to the introduction for this course. What you should know before you take this course. This is a beginner's course, so all you need to know really is to know your way around your computer. That should be sufficient to follow along with the course. Who should take this course? This is an absolute beginner's course. So it's designed for people who have never programmed before or developed before, also for anyone who wants to learn something new. What will you learn on the course? The course is practical and it's hands-on, so there are few projects to create. So we'll start with the installation of Python, and then we'll progress with some basic introduction to programming in Python. So you'll learn about variables, arithmetic functions, and so on. Then we'll go on to introduction to Tkinter. Tkinter is a Python module that is used to create GUIs. GUI stands for Graphical User Interface. Then we'll start creating the project. We'll start off by, we create a digital clock and then a countdown timer. Countdown timers are very useful. You can use that to count down to various events. We'll create a calculator, a weight conversion tool, a times table generator that will generate times tables, a random number generator, a number guessing game. We'll also have a bonus application that will be used to detect and remove vowels. The format of the course is video based and the duration is 4 hours. Thank you for watching, and I look forward to seeing you on the course. Bye for now. Hello, let's take a look at the projects we are going to create for this course. Project number 1 is going to be a digital clock. So we are going to be creating something like this. Project number 2 is going to be a countdown timer. Countdown timer are very useful to count down to various types of events. So this is the countdown timer. So we're going to be creating something like this, where you will set the end date for the type of event you want to count down to. Project number 3 is going to be a calculator. We are going to create a calculator like this, where we can do basic additions, multiplications, subtraction, and division. Okay, so project number 4 is going to be a weight conversion tool. So this is the weight conversion tool. So you enter your weight, for example, in feet, and you calculate it and convert it to meters. Project number 5 is going to be a times table generator. So this is what the times table generator looks like. You enter a number in there and click on times table, and it will generate the times table there. So if I click on 4 and click times table, you can see it generates 4 times table for me. So it can generate from 1 to 12 times table. Project number 6 is going to be a random number generator. So this is how the random number generator works. So you specify a range of numbers and it will generate numbers up to that range. So if I run the application here, if I go run, it will just generate random. You can see here it's generated a random set of numbers, which will tally with the range that you've specified. Project number 7 is a number guessing game. So this is how the number guessing game works. You specify a number. In my case, I specified a number from 1 to 70. So you need to enter a number. So if I enter 30, press enter, it tells me the number is too low. Say I say 80, say the number is too high, 60, too low. So you keep going on until you guess the right number. There's also a bonus project which is called vowel removal. So this is how the vowel removal works. You type in a message. For example, if I type in welcome and press enter, you can tell it removes all the vowels and gives you an output. Hello and welcome to this lecture. In this lecture, we'll be having a look at what is Python. Python is a case-sensitive, general-purpose, object-oriented programming language. By case-sensitive, I mean, for example, if you've got an object called Apple in uppercase and an object called Apple in lowercase, Python will treat them as two separate objects because one is an uppercase and the other is a lowercase. Also, Python is often referred to as a general purpose language. By general purpose, I mean it can be used to do a variety of things, both big and small. Python is an object-oriented programming language. Object-oriented means it treats everything as an object. For example, in the real world, a car is an object, a person is an object, a teacup is an object. So Python treats everything as an object. By programming language, a programming language is a language that is used to communicate with a computer. Computers respond to the command you tell them to do. So in other words, you can make a computer as smart as you want to be. What a programming language is just a set of instructions to tell the computer what to do. For example, if you want to bake a bread, there are steps you will take in baking the bread. Computer programming is the same way. If you want a computer to do something, you need to give it a set of instructions to follow. Python got its name from the British comedy group called Monty Python. So these are some images of the guys from the Monty Python comedy group, and there are their names displayed on this image here. Due to its flexibility, Python can be used to create games. Also, it can be used to create statistical and visual data. Does all that. Python can also be found used in some of the most famous websites on this planet. You can find the software either being used to build them or used to run these famous websites in one way or another. For example, you have Google uses Python in its app engine. You've got YouTube. YouTube uses Python as well. Facebook uses Python in some of its internal scripting. Instagram was created by Python using the Django framework. Pinterest is another famous social website, also created by the Django Python framework. Then you've got things like Yahoo Map, also created by Python. And then we've got Reddit. Reddit is a famous website. It was created also using Python. When we have NASA, the space company, uses some element of Python in some of the work it does. You've got the music streaming company called Spotify. They use Python as well. You've got the storage company, online storage, Dropbox, where you can save and retrieve documents. It was created using Python. The Washington Post also uses Python. Disney and Pixar, the animation company, also uses Python in some of its animation. Python also can be used to control robots, and they are also used in speech recognition and face recognition. Also, the biggest survey website on the world, SurveyMonkey, uses Python. So these are some of the famous software companies that are either built using Python or are using some parts of Python in running their software. In this lecture, we learned that Python is a programming language and that it is case sensitive. It is a general purpose language that can be used to perform a variety of duties or things. We saw some of the famous websites that Python has been involved in one way or the other. We learned that Python is an object-oriented programming language. It treats everything as an object. Python borrowed its name from the British comedy group known as Monty Python. Thank you so much for your time. Bye for now. Hello and welcome to this video. In this video, we are going to download and install Python. The link to the Python website is displayed on the screen. So I am now on the Python website, which is python.org. So click on download. When you click on the download or you hover your mouse over the download option, you will see the download for your operating system. It should automatically detect your operating system. If you are on a Mac, you should see the option for Mac displayed. If you don't see it displayed in this area, just click on it here from the menu that says Mac OS X and just follow the on-screen instructions. So I'm on a Windows, so I'm going to go for this option here, Python 3.62. So I'll click on that to begin the download. So once the download is completed, on the bottom here, just double click to run the installation. Click on run. So it tells you where Python is going to be installed. So if you want to take note, this is the location where your Python installation is going to go. It tells you here it's going to include the idle. The Python idle is kind of like the interactive shell where you can type in command. It also includes pip. Pip is what you use to run various Python packages. The pip is actually a package management system used to install and manage software packages written in Python. It's a bit like the Nodes package manager, NPM, in Nodes. There's also a box here that you need to check. So what that does, it will add Python to your environment path for your system. So I strongly recommend you click on that. So click add, and once you've checked that, just click on this area here that says install now, and that will begin the installation. If you get a prompt from your antivirus or user account control to accept the installation, just click yes to accept, and the installation should progress. Once the installation is complete, you'll see a message that says setup was successful. You can then close and exit Python. So that's it for this lecture. We have successfully downloaded and installed Python for Windows. Bye for now. Hello and welcome to this lecture. In this lecture, we'll be looking at the Python idle. The idle stands for Interactive Development Environment. It is an environment that you can use for learning. It consists of two main windows. the edit window, and the shell window. I have heard people say that the idle was also taken from Eric Idle, which is one of the members of the Monty Python comedy group. It's a British comedy group. Their name was used to name the Python programming language. So the group as a group is called Monty Python. There is a member of the group called Eric Idle. Some people say the idol was named after him. I'm not sure, but that's what some people say. So that's an image of the Monty Python group, and that's Eric there, Eric Idle. This is a more maybe recent picture of the Eric Idle. So some people say the idol is named after him. Let's have a look at what the idol looks like. So go to your start. If you are on a Windows computer, go to start, all programs. You should see the Python 3.5. If you click on that, you should see the idol there. So just click on the idol and it should load up. So this is what the Python idol looks like. It consists of two main windows, the edit window and then the shell. So this is the main shell. This is where you would experiment when you are writing Python code. It is a useful learning environment whereby you're writing, if you're writing little chunks of code, it's interactive, so you can see the output straight away. The other window is the edit window. So to access it, you go to File and go New File. And so this is what the edit window looks like. So when it opens up initially, it has the label Untitled. But when you save it with a name, then that changes. You can see there is a slight difference in the menu options of both windows. Both of them have got File, Edit. If you notice this one, the shell has got the shell. It's got a debug. Debug is a way of testing out your code. It's got options, windows, and help. So this has got the run here. So the menus are slightly different within both windows. I'm just going to minimize the edit window for now so we can focus on the Python shell. The Python shell is an interactive window and it acts as an interpreter. So it will interpret what you type into a format the computer can understand. So when you've got this three sign here that looks like right angles, if you got these signs here, it tells you that the Python shell is waiting for a command. So it's waiting for you to do something and it will respond. So let's do some basic maths. So let's do 3 plus 4. And then if you click on enter on your keyboard, you should get the result. There you go. 3 plus 4 give you 7. Let's do a minus this time. I'll do 6 minus 4 and click on enter. It gives me 2. Let's do a times this time. I'll do 9 times 6. The times in Python is represented by the asterisk symbol. So if you click enter, it will give you the output. So these are just basic arithmetic calculations that you can perform using Python inside the idle using the Python shell. The Python shell is referred to as the interactive mode. It's mainly used for testing, learning, and trying small things very quickly where you can see a response. The edit window, on the other hand, is used mainly for scripting, where you want to script or write proper code that will do something very useful, and a code that you can save and run later. If you want to do that, you would be using the edit window, which is this screen here. So this is where you would write your proper code or instructions for the computer to follow. And then when you save the file, you save it with a .py extension. So something like if you write in hello computer or something like that, when you're writing text in computer language, you need to surround it with quotes so that the computer can understand. So if I was to save something like this, you save it as, I'll save it, for example, save it on my desktop, and I'll just save it as hello.py. py is the extension for Python. So that's it saved there as a .py extension. So if you want to write proper code to do stuff, it's best to use the edit window, and then you can save your files. You can also run the Python shell from within the edit window by going run and then Python shell. This was the simple hello I wrote in Python and saved. So this is how your files will look like when you're saving from the edit window. In this lecture, we had a look at the Python idle, which is an integrated development environment that you can use for learning. It consists of two main windows where you can work from: the edit window that you can use to write proper code, Python code, and then the interactive shell window where you can experiment and write little chunks of code. Thank you so much for your time. I hope the video has been useful. Bye for now. Hello and welcome to this lecture. In this lecture, we will be looking at some reserved keywords in Python. Reserved means they are words that belong to the Python language. The language actually uses these words, so we can't use the words to name our variables, to name our list, or to name anything other than what the language has reserved them for. So these are some of the keywords in Python. So we can't use any of these keywords. If I was to create a variable and use any of these keywords, Python interpreter will complain because they are reserved words and should not be used. So let's try an example and use one of them, and you can see. I'm going to try and create a variable and give it a value of, say, 20. If I click enter, Python should complain. It tells you here that invalid syntax because we cannot use that word. That is a keyword in Python. It is reserved, so we cannot use it. In this brief lecture, we had a look at some of the keywords reserved for the Python language. We also tried to use one of them, this def here, to create a variable, and the interpreter complained. So keywords are reserved for the Python language. So take note of these keywords. So when you're creating variables or lists, try not to use them because it will not work. Thank you so much for your time. Bye for now. Hello and welcome to this lecture. In this lecture, we will be looking at some very basic arithmetic operators. Python uses these operators to perform various mathematical operations. So the basic operators are addition, and that's the symbol, subtraction, division, and multiplication. So let's see if we can do an example of each of them. I've got the Python shell open, so I'll start with the addition symbol. So I'm going to add two numbers. So all you do, if I want to add, for example, 7 plus 7, and hit enter on my keyboard, and I get 14. So if I do 8, take away 3, enter, gives me 5. I do 8, divide by 2, I should get 4. And the last one is a multiplication. So if I do 5, multiplication is identified by the asterisk. So if I do 5 times 2, I should get 10. So we've been able to illustrate using each of the operators. You can also use the operator for a string operation. A string refers to a text. For example, I could say hot plus dog, and hit enter, and that should give me hot dog. So you can also use it for a string. So in this example, we went through some basic arithmetic operators. Try and play around with this so you get used to them. Thank you so much for your time. Bye for now. Hello and welcome to this lecture. In this lecture, we'll be looking at comparison operators. Comparison operators are used to compare things. For example, is 1 less than 2? Is 3 greater than 2? So that's what they're used for, to compare. So let's try and create some examples. I've got my Python shell opened. So I'll start with the greater than sign. So I say is 6 greater than, is 6 greater than 5. If I click on enter, it should return true. So that's the greater than sign. Let's do less than. Is 3 less than 4. This should return true also. Next, let's do less than or equals 2. So say is 5 less than or equals to 5. So this should return true also. Oops, syntax error. Okay, I made an error with the syntax. Let's start again. It's 5 less than or equals to 5. Enter. See, because I left a gap, the interpreter got confused, thought I was trying to assign a variable. So I hit enter. You notice now it has worked now. So next we'll try the greater than sign, greater than or equals to. So say is 7 greater than or equals to 7. It should return true as well. Next, let's try an equals to sign. Don't forget, a single equals means you are assigning a value. So that when you're declaring a variable, you have to assign a value. That's when you use this single equals sign. So if you want to know if something is, say for example, is 2 plus 2 equals to 4, you use the double equals to sign. So let's try that. So if I say 2 plus 2 equals, you notice I've used the double equals. If I use the single equals, the interpreter will complain because they will think I'm trying to assign a variable. So I say 2 plus 2 equals to 4. So this should return true also. See? Finally, let's try one more. Let's try the not equals to. So if I say is 8 times 8 is not equals to 4, that should return true also. All right, so these are examples of comparison operators, mainly used to compare things. Thank you so much for watching. Bye for now. Hello and welcome to this lecture on variables. Variables are used to store or hold a piece of data inside the computer memory. So a variable is also a name for a value. For example, you could have a variable called fruit, and the value could be an apple. A variable can store data with all kinds of values. It can store a number. You could have a variable called number and get it store numbers, or it can store a string. A string is also referred to as a text. You can store a variable called hello, for example. Variable values can change. Once you have defined a variable value, you can also change it. If you, for example, define a variable called fruit and you assign it a value of apple, tomorrow you can change that value to maybe an orange or a pear. That's what it means by changing the value of a variable once it has been declared or created. So variables always reference or point to a piece of data. This is a box, and say for example I decided to call this box maybe chocolates or something. So I will be storing all kinds of chocolates inside this box. So this box here will act as a storage container for chocolates. Say today I can put in maybe cream chocolates. Tomorrow I can change the value. I can change that value from cream chocolates to maybe dark chocolates and so on. So that's in effect what a variable is a storage container for a piece of data. To experiment or with variables, let's open up our idle. So go to start if you're in Windows or programs, click on Python 3.5 and then click on the idle. So we're going to have a look inside the interactive shell. So this is the Python interactive shell. Once you've got these three signs that looks like chevrons here, once you got that sign with a mouse with the cursor flashing, that means the shell is waiting for instructions. So to create a variable, all you need to do is just write the name. Say I want to create a variable called fruits. So I'll do fruits, and then you must give it a value, and you assign the value using the equals to sign. I call it and name it apples, for example. Notice I have enclosed the value in quotes because it is a text or a string. So in computer language and in Python, you have to surround text in quotes so that the computer can understand. So I have now created a variable called fruits and the value of apples. So if I type in fruits, it will display apples. So let's go to the next line and type in fruits. And if I click on enter, it will display apples because I've given it the value there. However, I can also change the value from apples to oranges by typing in fruits, and I'll set the value to oranges and then click enter. If I now call that variable fruits and click enter, it should now show oranges because I have changed the value. So once you have declared or created a variable, you can always change the value. So creating a variable means declaring it, and the equals to sign operator is used to assign a value to the. Okay, let's create something a little bit more interesting. I want to find the cost of 2 items. So this is how I would go about it. So I will create 3 separate variables. The first will be price number 1. I give it a value of say 40. I'll create another variable. Price number 2. I give it a value of say 60. I create a third variable. I give it a value of total. And I'll make the total equals to price 1 plus price 2. So if I want to find the total price of price 1 and 2, I just need to type in total and then hit enter, and it gives me 100. So this is just simple ways how you can create variables. So variables are used to store values that you can change later. Thank you so much. I hope this introduction to variables has been useful. Try practicing within the Python shell, create some variables and play around with it. If you're going to create a variable that is a text, always remember to enclose the values in quotes. So creating variables and calling them. So when you create a variable, you are declaring a variable. When you're calling a variable, you just type in the name of the variable and it will display the value. Thanks so much for watching. Bye for now. Hello and welcome to this lecture on list. In this lecture, you will learn what is a list. You learn how to create a list. You learn about list index, how to reference an element from a list, how to edit a list, how to add to a list, and how to remove an element from a list. What is a list? A list is a kind of variable that stores multiple values as one. With variables, you can only store one value at a time. With a list, you can store multiple values as one. In some programming languages, a list is also referred to as an array. Lists are mutable. That means they can be edited. Once you've created a list, you can change it, you can delete elements from the list, you can add to the list. The list can contain numbers, strings are known as text, or they can contain both numbers and strings. They can also contain other lists. A list can also be referred to as a sequence of elements. Let's try and create a list. To do that, we need to go to our idle. So you go to Start, All Programs if you're on a Windows, and then click on Python 3.5, and then click on the idle. So we are going to create a list using the Python shell. So wherever you see the flashing cursor there, it means the shell is waiting for some instructions. I strongly advise you to type along with me. That way it will retain the knowledge you gain from here. So I'm going to create a list called fruits. So I'm going to type in fruits inside the Python shell. And then I'm going to give the fruits a value. So to assign a value to a list, you use the equals to sign, which is the assignment value. And then a list is identified by square brackets. So you place your list inside the square brackets. So let's type in the name of some fruits here. So I'm going to start with bananas. And then you separate each item in the list with a comma. Next, I'm going to type in oranges. Then grapes. And finally, apples. You have to make sure each element is enclosed in quotes because they are text so that the computer can understand them. So put quotes there. Notice as I put quotes, it changes to green. So quotes there. So quotes in between. And then another, I've spelled apples wrong. Okay. A quote there and a quote there. So we have now created a list called fruits, and it has 4 items in there. 1, 2, 3, 4. Next, we're going to look at indexes, how we'll reference each element in a list. Say if you've got a list like this, for example, if I wanted to reference one of these elements in the list, I will be using the index number. Indexing means the way they are numbered in the list. So with Python, the lists are 0-based indexes. That means the very first element is labeled 0, followed by 1, 2, and 3. So just know the very first is 0. So if I wanted to reference, say, oranges from this list called fruits, this is what I will do. I will type in fruits, and then the square bracket, and then I enclose the number 1 because the index for oranges is 1 and not 2. If I click enter, it should tell me oranges. So this is how you reference an element or an item from a list using their index numbers. Next, say we want to change an element in the list. Say if I wanted to change oranges to, say, kiwi, what I'll do, I'll type the name of the list, which is fruits, square brackets, insert the index. The index will reference these oranges here. Once I've done, and then I assign it a new value, and I type in kiwi. So this is now the new value for oranges. So to prove that, if I go fruits and then square brackets, type in 1 square brackets, it should show kiwi. So we've successfully changed the value of an element inside a list. So that's why lists are known as mutable. That means they can be changed. Say, for example, I wanted to add to this list. To do that, we use the append method. So we'll type in the name of the list, fruits dot append. Append means you are adding to the list, and then you give it, then you put the new value inside parentheses. And inside the parentheses, say for example, I want to include mangoes. So I type in mangoes. So this will now append to that list. So if I wanted to list the entire list, I'll come here and do a print function. I'll go print. And then type in fruits, which is the name of my list, and it will print all the elements in that list. Notice the mangoes here. This was an element I added on in the here using the append function. You can also remove elements from a list. Say for example, I wanted to remove this mangoes I've just added. You just go type in DL, which stands for delete, followed by the name of the list, followed by the index number. So this will be 0, 1, 2, 3, 4. So I'll type in 4 there and then hit enter. So if I do a print again, this mango should disappear from the list. Notice mango doesn't get displayed because it has been removed using the delete command. So in this lecture, we learned what a list is. We learned how to create a list. We learned about the list index, how to reference an element from a list, how to edit a list, how to add to a list, and also how to remove an element from a list. Thank you so much for your time. Try and practice using the Python shell. So go in and create several lists, try to append them and delete them. You can mix the list up with a text and a number, with a string and a number. Just play around with different values so you can get the hang of it. Thank you so much for your time. Bye for now. Hello and welcome to this lecture. In this lecture, we'll be looking at tuples. Tuples are like a list, but they cannot be edited. That means they are referred to as immutable list. They cannot be edited. With a list, you can make changes, but with the tuples, you cannot edit them. All right, let's create a tuple. Tuples are characterized by parentheses, whereas a list is characterized by square brackets. So let's create a tuple called, say, family. Then we give it a value. We use the equals to sign to assign a value. And then we put the values inside parentheses. Whereas in a list, the values are placed inside square brackets. So let's start. So you can use either double quotes or single quotes. So you say dad, comma, mom, comma, son, comma, daughter, comma. Anytime you're referring to a text is also known as a string. So wherever you're dealing with strings, you must enclose them in quotes. It doesn't matter, it could be single or double quotes, but you can't mix them. So if you start out with double, you need to end it with a double. Let's place one more member of the family. Let's place a pet. Put a dog there. So we have now created a tuple. Hit enter. So to call this tuple, all we need to do is type in family and click on enter, and it should display the list. All right, so it's displayed all the members of the tuple. With a list, you can change the values, but with a tuple, once it's been defined, you cannot change it. They are referred to as immutable list. That means they can't be changed. Thank you so much for watching. In this video, we had a look at what a tuple is. So try and create a few tuples yourself. Tuples can be useful where you are creating applications where you don't want the values or the variables to change. You can use tuples in such instances. Thank you and bye for now. Hello and welcome to this lecture. In this lecture, we'll be looking at how to use comments in Python. I've got my Python shell open. In Python, a comment is represented by the hash symbol. So wherever you see that, and any text that precedes that is ignored by the interpreter. So any code or text written where there is the hash sign, the interpreter ignores it. Let me show you an example. So let's type in hello world. And then enter. Notice nothing happened. It completely ignores it because it is a comment. Let's type the same comment without the hash. Enter. You say that it's returned hello world. Comments are useful. They help you describe your code to yourself and to others. Sometimes you may write code that you may forget the logic or what the code is meant to do. By leaving comments in between your codes, it helps you remember or describe what you're trying to do to yourself and also to other programmers. Hello and welcome to this lecture. In this lecture, we will be looking at how to slice a string. Slicing means cutting a string into smaller parts. Sometimes you may have a list and you may want to split the text or the string in the list. The way to do this is by slicing. So let's look at a simple example of slicing. I've got my Python shell opened. So I'm going to slice a text called strawberry. So to do slicing, you begin with the word piece, because you're going to split string or text in pieces. You type in piece equals to the text you're trying to split. I'll type in strawberry. So this is the text I am trying to split. The next line, you type in print, and then in parentheses you type in piece, followed by square brackets, and inside the square brackets is where you specify where you want to do the slicing. So I want to slice after the second character. So after 1, 2, I want it sliced. So I type in 2. Then you do that, and then you specify the second half where you want it sliced. So I want it sliced again after the 5th character. So it starts with a 0. So the S will be regarded as character 1. And then end the parentheses. So if I click enter, I should have a text called raw. Alright, so that is how slicing works. This is the simplest of the examples, so try and practice. The key thing is to know the position of the character of the text. Once you know it, then you can slice any text the way you want. Thank you so much for your time. Bye for now. Hello and welcome to this lecture. In this lecture, we will be writing a very simple program using the editor window. We will also learn how to save the program and how to run the program. So to begin, let's open up our idle. So you go Start, All Programs, click on Python 3.5, then click on the idle. Once you've got the idle open, go to File. We are going to be using the editor window. Go to File and go New File. So this is the window we are going to use to write our code. So for now, if you can just follow along with me, try and type as I also type the code. That way you will gain a better understanding. I will explain the code later. So let's begin by typing the word print. Okay, followed by parentheses, and inside the parentheses we will write some text asking a question. So let's say, how many chocolates have you got? So we'll type in how many, Alright, so the question I'm asking in this program is, how many chocolates do you have? So we need to put a question mark before there because we are asking a question. When you are using text, you need to enclose the text in quotes. So you can either have it in double quotes or single quotes, but you can't mix the quotes. So if you start with a double quotes, you must end with a double quotes. So this is the first line of the code. asking how many chocolates do you have. And then in the second line, I'm going to declare a variable, and the name of the variable will be amount. And I want the value to be equals to an input. That means what the user will type in. So it will be equals to, you use equals to assign a value to a variable. So the value I'm assigning here is an input function. That means this variable will change, so you have to pass in whatever number you want. And then I will add another print function. The print is a function. I'll type in print, and then enclose parentheses, and inside the parentheses I will write some text in response to the input that the user will key in. So I'll just say, wow. I'll just say, whoa. You have so many and then put a comma, and then I will add the response that the user will input in to the variables. Alright, so that will be the response. So notice I've used single quotes here at the beginning of the text, and that's the end of the single quote. I've used an operator here, which is a plus sign, and I'm saying it will add this text plus whatever value I've passed into this amount variable. So this is just a simple program. So that's it. So we just now need to save the program. So I'll go File, then I'll save as. I'll save it to my desktop, and I'll call it goodies.py. The py indicates it's a Python file. So I click on save. So I'll now exit that. So this is the file, the program we created. So to run the program, we need to reopen the idle. So click on Start, All Program, Python idle. Wait for the idle to open. This is the idle. And we go to File. We'll go to Recent File, which will be this one here. And we click on that. And it brings this up. We now go Run, and then go Run Module. Okay, there you go. So this is our program saying how many, which is this first line here, which is the first print function. How many chocolates do you have? And in the response here, I can say 16. You can type in whatever number you like, and then hit enter. And then it says, whoa, you have so many, 16. Okay, it's in response to the second print function. So we have just run the program we created. Let me run through the code with you quickly. The first line of the code here is a print function. What this does, it tells the computer the words you want to show on the screen. That's what the print function does. The second line here was we declared a variable called amount, and we gave it a value of input. So what that does, it means that the input command will tell the computer that the computer user will need to put something inside this parentheses for the data value. The third line here, which is a print function, tells the computer to print the text in between the parentheses and also add the value, which is this plus, add the value of the variable inputs. That means whatever value you put in there, it wants you to add that to the text. That's the result here, which is this wall you have many 16 because I typed in 16 here. So this is just a very simple program that we have written inside the editor window. In this lecture, we wrote a very simple program using the editor window. We saved the program and also ran the program. Thank you so much for your time. Bye for now. Hello and welcome to this lecture. In this lecture, we'll be looking at what a Boolean data type is. A Boolean data type can only have two values. Either it is true or it is false. Let's have a look at some examples. We're going to do some basic math using some arithmetic operators just to determine some values. The first I'm going to do is a true. So let's say 4 is greater than 2. If I hit enter on my keyboard, it should return to true. I do another one, say 7 is greater than 9. That should return false. Okay, so this is how you use a Boolean. So the values in a Boolean is either true or it is false. There are no other values, true or false. So anywhere you see a Python code with the output true or false, you know you are looking at a Boolean data type. Try and practice with a few examples so you can get familiar with the Boolean data type. Thank you so much for watching. Bye for now. Hello and welcome to this video. What is a class? In programming, a class basically is a template that is used to create objects. A class is something that contains structure. So it defines how something should be laid out or structured. However, it doesn't actually fill in the content. For example, I could have a class called a car, and I could say the car needs to have doors, it needs to have wheels, it needs to have seats. But I won't specify what the class won't specify what the name of the car would be or what type of seats or wheels it should have. Classes provide a means of bundling data and functionality together. So when you create a new class, it creates a new type of object, allowing new instances of that type to be made. So an instance is a specific copy of the class. So an instance of a class will have the templates for that class. Let's say I have a class called cars, and I want the cars to have, I'm building the template, so I want the class cars to have certain properties. So I want the car to have an engine, doors, tires, windows and lights. I also want the car to be able to perform some actions. So these are referred to as methods. For example, we want the car to be able to drive, to start, to stop and to park. So here we have laid out the template for the class called car. So if we wanted to create an instance of this class, an instance basically is a specific copy of the class that contains all the specified template content. So for example, I create a new instance of this car and another car and another car. So these are all instances of the car and they are known as objects. So these are all objects. In object-oriented programming, everything is known as an object. So these cars are all referred to as objects, and they are also instances of the class car. You can create a class for anything. For example, you can create a class called animals, and you can specify a template for what those animals should look like. You can create a class called plants, called motorcycles, anything. As long as you specify the template, what members of that class should contain, then you can create instances of that class object. Even though the instances of the objects have the content or assume the template of the car class, they can also have their own property. For example, this car here, this object called Nissan, has a property called yellow. So it has a yellow color as a property that is specific to the instance of this class. So the key thing to know that an instance is a specific copy of the class. So it contains all the content of the class. For example, it has an engine, it has doors, it has tires, it has windows. It can drive, it can start, it can stop, and it can park. So the key differences between a class and an instance is that the class is the actual template, while the instance is a specific copy of that template. Thanks for watching. Bye for now. Hello and welcome to this video. In this video, I'm going to do my best to explain what the self variable is. This variable tends to trip a lot of beginners up, so I just want to do my best to explain it the best way I can. The self variable basically is a reference to the current instance of the class or the object. So I'm going to illustrate by creating a very basic class. A class is basically a template for creating an object. So here is a basic class I have created. So I've created a class called restaurant, and then I've assigned it a property called bankrupt, which is currently set to false. Next, on line 3, I have a function. So I've assigned the class a function called open underscore branch, what that means is that this function open underscore branch will only happen if the value of the bankrupt is false, which means that the restaurant has money, so it's not bankrupt because the value is false. So now that we've created a class called restaurant, let's make an instance of that class. So I've created an instance of the class restaurant and I've called it X. So now X is a restaurant which has a property bankrupt and a function called open underscore branch, and we can access the property of the class by just typing in the name of the class, this class name here, the instance dot bankrupt. That will give us access to the property. The above command on line 8 can also be represented like this. So this x.bankrupt can also be represented as restaurant.bankrupt. So now you can see that this self here in line 3, the self refers to the bound variable or object. In the first case, it was X because we had assigned the restaurant class to X, whereas in the second case, it was referred to as restaurant. Now we have another restaurant called Y. So now we have the second restaurant called Y. By declaring the second instance of that restaurant, the self variable will know how to access the bankrupt value of Y and not X. So you can see here the bankrupt value of restaurant Y is true, while the bankrupt value of restaurant X is false. So this self here will reference the specific instance of that property. So the first argument of every class method, this also includes the init, is always a reference to the current instance of the class. So by convention, this argument is always called or named self. If you're using it with the init method, self refers to the newly created object. In other class method, it refers to the instance whose method was called. We can re-represent this code here in a different format. So we represented it again here. This keyword also represents a reference to the current instance of the method or object. So you could use this, or you could use the self. So anyway you see that, it means they are referring to the current instance of the class or the object. So that's it for this lecture on the self variable. I hope the explanation has made sense. Thanks for watching. Bye for now. Hello and welcome to this lecture. What is Tkinter? Tkinter is a Python module or package used to create GUI applications. GUI stands for Graphical User Interface. It is a cross-platform GUI toolkit. That means it will work on Windows, Mac, Unix operating systems. It usually comes bundled with the installation of Python. So if you've already got Python installed, you should have Tkinter. Tkinter provides a GUI interface for the TCL or TK, which are available, or which is available on most operating systems. So it provides an interface to the TK GUI toolkit, which is available in most operating systems, which includes Unix, Windows, and Mac. The TK itself is not part of Python. It is maintained by Active State. You can check from the command line to see if Tkinter has been installed properly. So let's test that. So open your command line. I've got mine opened, and just type in Python space hyphen m lowercase m space Tkinter, and then press enter. What should happen if Tkinter has been installed properly? It should bring up a window that will demonstrate or show a simple TK interface. So let's do that. Press enter. There you go. So this is a proof that Tkinter has been installed properly. This is the little symbol here for Tkinter, so you can drag that. There you go. So that shows that you have got Tkinter installed properly, because Tkinter comes bundled with the installation of Python. So excellent. We have proof that Tkinter is installed properly. Let's click on the quit and it should disappear. Most of the time, all you'll need is just the Tkinter module. However, the Tkinter module also has other additional modules that can come in useful. So just a quick summary, Tkinter is used to create graphical user interface, also known as GUI applications, and it basically acts as a Python interface to the TCL and TK GUI toolkit. That's it for this lecture on Tkinter. What you can take away from this is just know that the way you create graphical user applications with Python is by using the Tkinter module. Thanks for watching. Bye for now. Hello and welcome. In this lecture, we are going to briefly explore the TK and Tcl. TK is an open source tool used for GUI interface development. GUI stands for graphical user interface. So TK is an open source toolkit used for GUI development or GUI interface development. GUI stands for graphical user interface. Open source means it is free to use. TK provides a library of interactive widgets. These widgets are also known as GUI elements, which commonly are used in desktop applications. Okay, and they include things like menus, buttons, windows, text input field, and so on. TK was developed way back in the early 90s as an extension for a scripting language called Tool Command Language, which has been abbreviated to TCL and commonly pronounced as Tcl. So it was developed as an extension to Tcl, or Tool Command Language. It is also designed to be platform independent. That means it can be run on most versions of Windows, Mac OS, Unix, or Linux. So in effect, if you develop your application, your GUI application using TK, it will be able to run on most common operating system, as it is platform independent. Let's have an illustration of how the Tcl process works. So you have a Tkinter as a standard Python application interface. Okay, so this is the standard Python interface and is used to access the TK framework. So what happens when your Python program makes a call to the Tkinter? So your Python application makes a call to Tkinter. It then accesses the Tkinter Python modules, all right, which will include functions in the Tkinter package. This package is written in Python. So these functions, what they'll do, they will now pass the commands from your Python program and format them so that they look like commands from a TK script. They are then passed to the TK, they then pass to the _TK inter extension module, which is written and compiled by C, or in the C programming language, and is able to make calls into the widgets in the TK library, which is implemented using a combination of C and Tcl, which is the tool command language, which is a scripting language. And then at the bottom end of the chain, the TK widgets then utilizes the xlib library to draw, which is used to draw graphics. Okay, it will use that to draw graphics. And so let's run through this illustration again. So you get the Python program makes a call to the Tkinter module, okay, which can be used to access the functions in the Tkinter package, which is written, this package here, which is written in Python. So these functions, okay, then pass the commands from your application, okay, and format them to look like commands from the TK script. That's what it does, okay? And then they are passed to the Tkinter extension, this module, and the Tkinter extension module. This module is written and compiled in the C programming language. What happens then is that it is able, this module here is able to make calls into the widgets in the TK library, which is implemented by using a combination. Okay, it makes a call to the TK widgets, which is implemented by using a combination of the C and Tcl. Using a combination of C and Tcl, which is the tool command language, using a combination of that. And here, and then you've got the Tcl, which is using the C programming language. Once that is done, the TK widget utilizes this library here, the xlib, which is used to actually draw graphics on the screen. All right. The TK version 8.0, with that, it introduces new GUI elements, which are themed to match the appearance of the standard elements in your operating system. So for example, if I run the Python Tkinter script to create, for example, a login screen in Windows, it will take on the native Windows appearance. Whereas if I run it in a Mac OS, it will change its appearance to reflect the Mac theme. This is useful because it allows you to write a cross-platform GUI application which will maintain the look and feel of the operating system on which it's currently running. So that's it for this lecture on the TK and Tcl. Thanks for watching. Bye for now. Hello and welcome. In this lecture, I will guide you how you can install Python 3 and Tcl TK for Mac. Most installation of Python on a Mac are version 2x, so you rarely find a version 3 pre-installed. It's usually version 2.7 or so on a Mac. So I'll guide you how you can install version 3x and also the latest versions of the Tkinter for Mac. This is important so that you can utilize the Tkinter module. So go to the Python download page. So you just type in Python download in your web browser, or you could go to the link there. So you type in python.org/downloads. So once you've got the download page, you just scroll down to the bottom here, where it's got the various, and just click on the one under downloads, click on Mac OS X, click on that, and you scroll down. It says the latest releases for version 3 is 3.52, so click on this here, and this is a Python 3.2 release. So you scroll down through the downloads and have a look, and the one you should be clicking on is this one here that says for Mac OS X 10.6 and later. So you click on that to begin the download. Once the download is completed, so you navigate to your download folder in the Mac and double click on the disk image to begin the installation. So by double clicking on that from your download folder, that should mount the image. I haven't got a Mac at the moment, so I'm trying as much as possible to give you as much information as possible. So once you've navigated to your downloads folder and double clicked on the disk image, what that does is should mount the image, and when it opens, you can do a control-click on the .mpkg file. Once you do that, it will give you a menu where you can choose to open the file. Okay, so by selecting open, what that will do, it will bring up the Python installer. So click to continue to progress through the menus. Eventually, what should happen, it should prompt you to agree to the software license agreement. Click the agree button and you should see an installation button. When you click on the installation button, it will prompt you for your administrative password. Enter the password and then click the install software button. After the installer finishes, you should have Python 3.4 on your machine. Once that's done, you need to download the Tkinter. To download and install the latest version of Tkinter for Mac, you need to go to this link here that I have got displayed on the screen, and that will take you to the download site. So this is the download site for the Tkinter for Mac OS. So just scroll down and look for your version. So for the latest version, you can click on that, the recommended Tkinter. Click on that, and that will take you to the active state website. So just click on that. And this is the active state website that manages the Tkinter. So scroll down to the page and look for the download that matches your operating system. So select your relevant one. So select this one, Mac disk image. So once the download is completed, you navigate to your download folder and then double click on the image file to mount it. So do a control-click to select the PKG file and choose open from the menu. This brings up the installer for active states, active TKL 8 point whatever version is displayed, which is kind of like similar to the Python installation. So click continue and then navigate the menu. You need to agree, select agree when you are prompted to agree to the software license agreement. And when you see the install button, click on that. And again, you may be prompted to enter your username and password. Enter your credentials and then hit the install button. After the active Tcode installation is completed, you can eject the disk image once you finish, and you can go to your Finder on your Mac, eject the Python 3.5, and also eject the active Tcode. So, all right. To test your installation has been successful, if you open up your Python idle and just type in import Tkinter, make sure the Tkinter is all in lowercase. If you hit return and if you get something like this, if no error messages, that means you have installed Tkinter correctly with Python upgrade 3.52. So that's it. If you get no errors, that means you have successfully installed the Python and the Tkinter. Thanks for watching. Bye for now. Hello and welcome. In this lecture, we are going to create our first Python GUI app using Tkinter. Let's open up our Python idle. We'll go to Start, All Program, click on the Python folder and click on idle. So this is the shell. So we open up a new file, new file. And we'll save this file as, save it on the desktop. I'll save it as Hello World. All right, so it'll be a basic application that displays Hello World on the screen. Before you can use any Python module, you have to import it. So here we'll type in from Tkinter import. By using the asterisk, what that means is that it will import all the functions and variables from the Tkinter package. Also notice the Tkinter is in lower case. In earlier versions of Python, like Python 2.x, is usually in uppercase. Next, we are going to use a tk constructor method to create a new top level widget. Okay, so this will be the main window and we're going to give it a variable named root. So let's do that. So type in root equals to tk. So this is a constructor method. So this tk constructor method has been assigned to this variable called root, and what that will do, it will create a new top level widget, which will be the main window for the application. The next thing we'll need to do, we need to create a label that we'll use to display the text hello world. So to create the label, we'll type in label. So the text we'll type will become a child of the root. So we'll type in root, comma, text, equals to hello world. Okay, and then a comma. No, I'll leave that. I don't want to add any more text. But we need to attach a method called pack. So it'll be dot pack. What this will do, this is a method that will display the text in the window. Without this pack, nothing gets displayed in the window. So this dot pack method is what will display the text or content in the window or GUI. So we've created a label, okay, with the text hello world, which is a child of the root window. And we've also used the dot pack geometry management method. So the dot pack is a geometry management method. We've used that to place the text in the window of the GUI. The last thing we're going to do is we're going to create a main loop for the application. So what this will do, we want it to be a continuous loop that will keep running to keep the window active. So the only way we can exit it is by exiting the application. So without creating this kind of infinite loop, the application will probably just close. So to create the loop, we'll type in root dot main loop. And what this will do, it will keep the window active for the application. So without this, once the text is displayed, the window might close. So we want the window to be active, so the application will keep looping through and running to keep the window active. So let's save the code and we can run the module and see if everything works out. So go run and click on run module. And that's the window there. I just drag it along. Okay, there you go. So that is the hello world. So without the dot pack, this text will not be displayed. All right, so we have successfully created our first Python GUI application using Tkinter. That's it for this lecture. Thank you for watching. Bye for now. Hello and welcome to this video. This is going to be a two-part video where we are going to create a digital clock using Python from scratch. The first thing you need to do is open up the Python shell, and you can access the shell via the Python folder. So if you go to your programs menu and inside the Python folder, just click on this, that is a Python idle, and that will open up the shell. Once you've got the shell open, we need to open up a new file. So you click file and click new file. So this new file here is where we will actually write the program, and any errors that occur will be displayed in the shell. We are going to use a few Python libraries, so we need to import them before we use them. The first library we're going to import is the Tkinter library. So we need to import that by typing in from in lowercase space and then the word Tkinter space import and then asterisk, and this will import the Tkinter library, so it's available for us to use. So it's the first line you have to put in if you are going to use the Tkinter in your program. Tkinter is a library that is used to build user interfaces or interfaces in general. So we're going to import a sub library also from Tkinter. So we say from Tkinter. This one is going to be called TTK. Next, we're going to import the font. We want to use a font. Tkinter also has fonts you can use. So we'll do Tkinter import font. Next, we are going to import the time module because we need to use that. So import time. Next thing I'm going to do is import a module for date time. We're going to make reference to that. So that's it. We've got all our libraries. Next, want to create a function. So def is what you use to define a function. And I'm going to call this function quit. So we'll use this to quit the application. And I'm going to pass in the arguments args and colon. Next, we'll type in root dot destroy. Inside the function we've just defined, we've got an asterisk followed by the word args. Basically what that is used for is used inside function definitions, and it's used to pass a non-keyworded variable length. So it will allow you to pass non-keyworded variable length arguments as a list, kind of like an array. So it allows you to pass several arguments, provided they are not keywords. Keywords sometimes are reserved for the program, so you can't actually use them. Next, we've got the root.destroy method. What this will do, it will cause the main loop to exit. So when you, at the end of the day, when you close the window for the application, that's the method that will trigger the application to close. It will just close the session. The next thing we're going to do is create another function. This will be for our clock. So we're going to say df. I'm going to call it clock underscore time. You can call it whatever you want. It doesn't really matter. So I'm just calling it clock. All right. And you put a colon after that. Next thing I want to do is define a variable. So I'm going to call the variable time, and I am going to set this variable to equals to the date time. Don't forget we imported the date time, so we can use it now. So I'll do date time dot now, which will give us to the current time. The date.time method returns the current time also in milliseconds. So I want to avoid that. So to do that, I'll need to format the time using a special format function. So to do that, I've got to reference the time variable again, and I'm going to have to set that to equals to, and I'll wrap it round the variable dot. This is the special function here. It's called strf time. This is used to, it's a function used to format the time based on the arguments you've passed in. So I'm going to enclose that in double quotes, and I'll pass in the format I want. So I want the hour, a colon, and I want the minute, I put colon, and I want the seconds, and I close the double quotes, close the parentheses and close the other parentheses. Next thing I want to do is find a way to display our time. So we're going to do text, we'll say txt, which is text. We're going to set that to equals to the time variable. So there is a function or method called set.text.time, which text.set. So this is a method, and we're passing in this time variable here as the value. Next, we want to trigger the clock so that it starts after every 1 millisecond. So we do root dot after, and inside parentheses we pass in the milliseconds, a comma, and then we pass in the function, which is the clock underscore time. So that's it. So we'll end this video here, and in part 2 we will continue. So thanks for watching, and bye for now. Hello and welcome to the part 2 of creating a digital clock using Python. In this part we are going to build the user interface. So we start by typing in root, and we set that to equals to tk. The tk basically creates the root. Everything that you put on your screen, whether it is a text box, a button, or an image, is known as a widget, and they must all be placed in the root. So the root is kind of like a basket that you put all your widgets in. So let's add some more to this root. Next thing I want to do is set the attribute. So I'll do root dot attributes, and inside parentheses I'm going to specify the attributes. So I'm going to set the value for full screen. If you want your application to display in full screen, then you set the value to true. When it's full screen, it's hard to resize it. So I'm going to set that to false. But if you want yours to be full screen where it can't be resized, then you can set it to true. I would, just play around with it and see, but set it to false because it will make it easier for you to resize it to your taste. I want to set the background color for the clock. I want to set it to black. So you do root dot configure, and then in parentheses you type in the word background, and you set it to whatever color you want. I'm going to set it to black, so I type in black. Make sure you always match up your quotes. Next thing I want to do, I need you to be able to click on the X button. You can see this X here. I want to create one for the application so that you can exit when you click that. So I'll do root dot bind. So I'm going to bind this function here called quit. So I'll wrap that in parentheses. So I'll attach a label called X, and that X I'm going to also pass in the function called quit. So this root.bind will take in 2 arguments, this value X and then quit. This is the function I'd already defined. I'm going to trigger the clock again. To start, to do root dot after every milliseconds I want the clock to start. So we'll call the clock underscore function, which is clock underscore time, and that will trigger the clock to start. I'd call this variable this here, and I'm setting that to a string variable function. In order to save time, I have completed the code. So let me just go through what I have added on. So here I've created a variable called fnt and set that to equals to font.font. So basically I'm using I specify the font family here called Helvetica, and I've set that the size of the font to be 120. The weight, that means I want it to be bold. And here I have defined this text txt variable, and I've set that to equals to a string var. What this means is that this will hold a string value by default. Okay, and here I am using this LBL. It's a label variable, and I'm referencing this TTK, which is a sub-module of Tkinter. So here is where we are setting the properties for the clock. So we're setting the background, which is the foreground color of the clock, is going to be white, while the background of the actual clock, the text, is going to be black. This is different from this. This relates to the screen. This we're just setting this properties here. These settings are for the actual window, while these ones here are for the actual clock itself, the text that the clock displays. That's what these settings are for. That's the foreground color, and that's the background color, and this here is used to anchor it to the center. Here I've used the relx and the rely. Basically these are geometric functions in Tkinter. You basically use them to give a position that is relative to the window, while the anchor here is used to actually center the widget. Finally, on this line here, we've got the root.main loop. This basically handles the Tkinter event loop. So basically it keeps the application or the clock running until the window is closed. So that is it. So the clock is basically built. What I would advise you to is make sure you format. There's options here to format. You can indent. Make sure your indentation is like mine, because this editor is very fussy. So if you don't indent things properly, it will complain. So make sure your indentation is spot on. If you get any errors, usually the errors will be on this side in the shell. Just response to it. Okay, so I'm just going to click save. Now I want to run the clock, so you can run it by